curvilinear motion, the path is no longer a straight line. From this graph, you can see the object is moving from point to point in a curvilinear motion. We can use the rectangular coordinate to quantify this motion, and the displacement x vector is given by the x, y, z magnitude in terms of the direction I, j, k. To find the velocity, you need to differentiate the x with respect to time. Then dx over dt is equal to your velocity at x direction. dy over dt is the vy. dz over dt is the vz. The direction of the velocity is always tangent to the curvilinear path. For example, if let's say the particle is moving from this point to this point, so you see the velocity is tangent to the path. And the direction of velocity here is tangent to the path here as well. You can differentiate the velocity with respect to time to obtain the acceleration. For example, ax is equal to, differentiate the vx with respect to time, ay is equal to differentiate the vy with respect to time, and az is equal to dvz divided by dt. And you must know the direction for acceleration is different with the direction for the velocity. So direction for velocity is tangent to the curvilinear path, but the direction for acceleration is not tangent. Let's use the rectangular coordinate to solve the problem 8. So you have one object travels from the origin. Let's say this is the origin, and then move along with a curved path like this. So you have curved path like this. Given the horizontal velocity is equal to at_t, so horizontal velocity is equal to 8t, and if we assume the horizontal direction is x direction, vertical direction is y direction, then we can let v to be vx. From this formula, you can foresee that the velocity is increasing over the time. And you want to find the magnitude of the velocity, acceleration, as well as the distance from the origin at 2 seconds. So at here, origin is equal to t equal to 0. So over the time, it will move according to the curved path here. And let's say at t equal to 2 here, we want to know what is the velocity, acceleration, as well as the, so please correct this, this should be displacement from the origin. So magnitude of displacement is written by this symbol. It can be equal to taking the square root of x squared plus the y squared plus the z squared. So to find the magnitude of velocity by using same method, okay, so vx squared plus vy squared plus vz squared. So you can also find the magnitude of acceleration by using the same method. First of all, since the velocity in the horizontal direction, vx is equal to 8t, so we know dx is equal to dx over dt. Therefore, by integrate both sides, and then with respect to the dt, on the right hand side dt can be cancelled, you have the integrate dx. On the left hand side, you have integrate 8t dt. So the initial time and initial displacement at this point, so at t equal to 0, your x is 0. Therefore, we can substitute 0 inside. And if you solve the integration, you should obtain your x equal to 4t squared. Since the path is given y in terms of x, so you can substitute the x inside and change the y into yt function. Since this is 2D, our displacement vector is x equal to xi plus yj. So x is the xt function here. So we can substitute inside, and your y function is equal to 2t cubed. So after you substitute, you should obtain this result. And we want to know what is the magnitude of displacement at t equal to 2. Therefore, you substitute 2 inside. So 4 multiplied 2 squared, you obtain 16. 2 multiplied 2 power of 3, you obtain 16. So this is the displacement vector. And then to find the magnitude here, you need to take the square root 16 square plus 16 square, which gives you 22.6 meters. So you success to know at t equal to 2, your x here is equal to 16. And the y position here is equal to 16 as well. And you find the magnitude of displacement to be 22.6, which is the shortest distance from 0 to this point. So this is the magnitude of displacement that you found here. You need to be careful, the displacement that you calculate here is different with the distance here. So to compute this distance, then you need to use the arc length formula, which is this. So you integrate in the x direction from 0 to 2, and then you need to take the square root 1 plus dy over dx squared. So how to find the dy over dx? So you have your y here, so you can find the dy over dx here. In this class, we will only cover the displacement, not the distance. So we won't use this. Determination of the distance is out of the scope. Once you find the displacement vector, we can easily get the velocity vector. So for the dx over dt is given here. If you differentiate the 4t squared, then you can get the same answer. Differentiate 2t power of 3, then you get 6t squared. Substitute t equal to 2 inside, then you get vx to be 16 and your vy to be 24. Then you can find the magnitude of the velocity by using this formula, and you get 28.8. So this is the graphical representation for the velocity. So in the x direction, you have the velocity equal to 16. Y direction, you have 24. And when you find the magnitude of the velocity 28.8, then this is the resultant. You can also find the direction for the velocity here by forming a triangular. So 24 divided by 16 here, you obtain the tangent theta. And this direction angle is equal to the arctangent 24 divided by 16, and you should get 0.982. This is in radian. If you want to convert to the degree, then you need to multiply 180 divided by pi. Then you should get the velocity angle to be 56.3 degrees. If you compare the direction of the velocity with the curvilinear path here, then you found this velocity direction is tangent to the curvilinear path. We can continue to differentiate the velocity to obtain the acceleration. So differentiate 8t, you obtain 8, and then differentiate 6t squared, you obtain 12t. At t equal to 2, then this will remain, and then 12t will become 24. By using this formula, then you can find the magnitude of the acceleration to be 25.3. So this is the graphical representation for the acceleration. At t equal to 2, then the acceleration in x direction is 8 here, and your ay is 24. Then the resultant is 25.3. We can also find the angle for the acceleration vector here. From this triangle, the tangent angle is equal to 24 divided by 8. So the acceleration direction is the theta, where it can be found from the arctangent 24 divided by 8. Then you get 1.28 radian. To find it in degree, you need to multiply 180 divided by pi. Then you obtain the direction to be 71.6 degrees away from the horizontal direction here. So you see the direction of the acceleration, 71.6 degrees, is not the same with the velocity direction that you compute earlier. The main difference is the velocity direction will be always tangent to the curvilinear path, and in this case you see the acceleration direction is not tangent to the curvilinear path here. For the curvilinear motion with constant acceleration, we can still use the ABC equation to solve the problem. In this problem 9, we have the projectile motion where you throw the ball in a particular angle. So this is called the initial velocity, and it can be separated into horizontal component. So since your horizontal axis is x-axis, then we can let it to be v0x. And for the vertical axis, it is y-axis, then the vertical component for the initial velocity is v0y. The initial position for the ball is P, and the position is given by x0 and y0 here. After you throw the ball will move in projectile motion like this. And what we want to know is the displacement, velocity, and acceleration along this projectile motion. Once you throw the ball, the only force acting on the ball is the gravity force. Therefore, the ball will experience acceleration in this direction, which is in negative y direction here. So you obtain for your vertical motion here, the acceleration in the y direction is negative 9.81. By using equation B, for the vertical motion here, so your displacement will be equal to y. So initial displacement is y0. So velocity at the y component is v0y. T remains. The constant acceleration is in y direction, so it's ay, or is equal to negative g. So by substituting this inside, you should obtain this equation. By using equation A, so the velocity at y component is equal to the initial velocity at y component, and then the acceleration in y component is negative g. So by substitute all the information, you should obtain this equation. By using the same approach, you substitute the y component to the equation C. So v here becomes vy, v0 becomes v0y, AC becomes AY, which is equal to negative G. And then displacement here is Y. Initial displacement is Y0. Therefore, you obtain this equation. By using this equation, then we can find the acceleration, displacement, as well as the velocity in the vertical motion. Let's continue with the horizontal motion. So for the acceleration, you see there is no force acting on the ball in the horizontal direction. Therefore, the acceleration in x direction will be equal to 0. Since the acceleration is 0, then for this term here can be equal to 0. Let's substitute the displacement to be x, initial displacement to be x0, initial velocity to be v0x, then you can obtain this equation. And then substitute velocity to be vx, initial velocity to be v0x here. Then you should obtain this equation. And you see for the equation C, if you take the square root on both sides, you obtain the same equation. These three equations can be used to find the kinematic parameters for the displacement, velocity, and although we perform the calculation for the horizontal motion and vertical motion separately, for the projectile motion, you must know that the horizontal and vertical motion occurs at the same time. Let's try to solve this problem. So you see the path of the projectile is given here, and the object has an initial velocity 30 meters per second. Means that the ball is thrown in this direction at 30 meters per second. The direction of the velocity is perpendicular to the slope. So this is the slope, and you have 30 degrees. So over here 90 degrees, you throw the ball. So this is your initial velocity. And we want to find the distance d, which is located from here to here. To solve this problem, first of all, you need to let y to be the vertical direction, and you let x to be the horizontal direction. Then you need to decompose the displacement as well as the initial velocity into x and y components. From this geometry, since you know 30 degrees here, therefore d cos 30 is the x component, d sin 30 is the y component. So at the initial point here, 0, you have the origin 0, 0. And when you throw the ball and hit to the ground here, so at this position, the displacement is xy, where your x is equal to d cos 30 degree, and your y is equal to negative d sin 30 degree. To decompose the initial velocity to the x component, we need the angle here. So far we only know here you have 30 degree. So since this is a triangle, so over here is 90, over here is 60. So since this is horizontal, therefore you obtain 30 degree here. Since this is 90 degree, we obtain the angle here to be 60. So you can find the velocity at the x component to be 30 cos 60. Then you should get the answer to be 15. If you calculate the angle here, then you should get 30 degree. So if you compute 30 sin 30, then you should get the same thing. To find the initial velocity at the y direction, you can use 30 sin 60 or 30 cos 30, then you should get 26 meter per second. From previous analysis, you should know that for the horizontal motion, your acceleration in x direction is 0. For the y direction, your acceleration is negative g. By using the equation b here, we can get this equation. Then you need to substitute the information inside. So for the x is here is equal to d cos 30. The initial displacement is here, which is equal to 0. The initial velocity in x direction is here, which is equal to 15. The time taken to reach to this point is unknown, so we just remain. So for the y information, you can obtain from here negative d sin 30. For the initial velocity, it will be equal to 0. And then initial velocity, it will be equal to 26. G is 9.81. After substitute all the parameters, then you should be able to obtain these two equations. And you have the d unknown and the t unknown. By solving these two equations, you should obtain this answer. So the time taken for the ball to hit the ground here is equal to 7.06 seconds, and the displacement from the origin position to the final point here is equal to 122 meters.